हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्स अप? कैसे हैं सब लोग? क्या हाल चाल? अपोना खेमेना चेन येल्लावनारू. Please guys do join me fast so that we can start our session without any delay. This is Chandra Shekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. And as you all know, we are running the atomic series for BARC and HAL aspirants for this year 2022. And this is a online crash course for the mechanical engineering aspirants. And today we are going to have the wonderful question practice from the topic thermodynamics. First of all, do let me know if I'm audible and visible to everyone. Hi Amarendra, welcome to the session. Please write in the comment section to mark your presence so that we can start our session. Am I audible and visible to everyone? Rohan, good evening, welcome. So today's topic, I have brought the beautiful, conceptual, important questions from the basic concepts of thermodynamics as well as the first law. And tomorrow we will be having another session, Thermodynamics Part 2, at the same time on the same platform, that is BYJU'S English YouTube channel at 4 p.m. And tomorrow we will discuss the questions from second law of thermodynamics and entropy. And there will be one more session to complete our thermodynamics, that is for applied thermodynamics, that is on Wednesday. All right. So this is, in these three sessions, we are completing the important concepts, important topics, important questions which can be expected in your upcoming BARC examination. Yes. Amarendra, you need to talk to the concerned person actually. I cannot. Which free subscription you are talking about? You should contact the management, BYJU'S management. They will guide you whether it is possible or not. Hi Hemant, good evening. Shubham, good afternoon, welcome. So you should contact the BYJU'S management, BYJU'S Exam Prep. All right. Good evening, welcome to the session. Am I audible and visible to everyone? Please do let me know. Can you guys hear me? So shall we start? Please keep your pen, notebook and calculator. I have brought total 16 questions from the different areas, important areas of basic concept and first law. So keep your pen, notebook and calculator so that you should solve the question correctly and try to check your weaknesses, try to check your weak areas which can be improved further. The more you practice, the more you become comfortable with the concept. All right. This is for mechanical, Amarendra. Thermodynamics, is it there in civil also? This is purely for mechanical engineering students. We will be having fluid mechanics session, which will be common for mechanical and civil. We have already taken one session on fluid mechanics. If you were part of this series, if you are following this atomic series from the beginning, we have already had one session for fluid mechanics part 1, that is fluid statics and fluid properties. I will bring the next part of the fluid mechanics, that is for kinematics and dynamics as well as the hydraulic machines. So keep following this series, and this is my quick introduction. Most of the students already know about me. I am a mechanical engineering graduate from IIT Delhi and also an engineering services examination qualified. For those who are meeting me for the first time, those who are here on this platform for the first time, do not forget to like, share and subscribe our BYJU'S YouTube channels. One is Hindi channel as well as another is English channel. We are providing you the complete solution for GATE, ESE and other competitive examination. So you will be getting the notification for all our free classes which we run from time to time. All right. So shall we start? Please make some noise so that we can start our session. Are you all ready to explore? Rahul, Gradeup is now BYJU'S. I am still there, but it is no more Gradeup. It has become BYJU'S now. Alright, so there is the first question on the screen. Please do let me know the answer through the comment section. Everyone, please give it a try. The first question is the ideal gas law is valid for. You are having 4 options. Please let me know the correct option as per your understanding. What is ideal gas law? First of all, do you know what is ideal gas law? That is PV is equal to MRT. That is ideal gas equation. Or we can say PV is directly proportional to temperature. That is ideal gas law. This is called as ideal gas law. It is valid for which? The correct answer. So how do I remember the ideal gas law is valid for the fluids or the gases having low density? Gases with low density. And when does a gas is having low density? At low pressure and high temperature. Low pressure and high temperature. So the correct answer is option D. D is the right one. Surya, it is not B. Satya, Rahul, Shubham, Ankit, Rohan, Rahul, so many students. Anjali, good. Well done, guys. Well done. The correct answer to this question is option D. It is option D. The gases which are having very low density can be treated as ideal gas and they are following the ideal gas law. The gases at low pressure and high temperature. Let us move to the next one. Next question on the screen. Next question on the screen. Question number 2. For an ideal gas, the gas which are following the ideal gas law are known as ideal gas. Undergoing a throttling process. What is throttling? What is throttling process? Any idea about throttling process? Throttling process is flow through restricted passage. What is the answer to the second question? Everyone, please let me know through the comment section your answer. Select your answer. Write your answer in the comment box. Flow through restricted passage. Is known as throttling. Examples are flow through adjustable wall, flow through porous membrane, flow through porous plug, or the flow through capillary tube. These are some of the examples of capillary tube. These are some of the examples. So the throttling process is it reversible or irreversible? Yes, Rohan, it is highly irreversible. Throttling is irreversible process and there is no heat transfer because it is irreversible process and it is the throttling process is happening in insulated plug. So there is no heat transfer, there is no work transfer, and there is no change in potential energy and kinetic energy. So from the steady flow energy equation, we can say H1 will be equal to H2. Throttling is also called as isenthalpic. Throttling is isenthalpic, and because it is ideal gas, so for ideal gas, H is a function of temperature only. For ideal gas, H is a function of temperature only, and because H1 is equal to H2, then T1 is equal to T2. T1 will be equal to T2. For an ideal gas, because it is an ideal gas, then the throttling will give rise to the same temperature at inlet and outlet. Option A is the correct answer. It is option A which is correct. Clear? But if it would have been a real gas, if the gas would have been non-ideal, then what about T2? Will it be more than T1 or will it be less than T1? Can you just let me know? If the throttling process would have been undergone by a real gas, then what would have been the temperature T2? More than T1, less than T1, or same as T1? Does it matter whether the throttling process is undergone by ideal gas or non-ideal gas? What will happen to the temperature across the throttling process? Hi Kevin, Kevin, welcome. It is Joule Thompson coefficient, del T by del P at constant enthalpy. That is Joule Thompson coefficient, which decide whether there is an increase in temperature or decrease in temperature. Joule Thompson coefficient, that is the slope of isenthalpic process. Slope of isenthalpic. If this is less than 0, throttling will always give rise to decrease in pressure. Throttling will always give rise to decrease in pressure, isn't it? Acha, this is Manwalk. All right. Hi Ankit. It will decided by the Joule Thompson coefficient. Pressure will, if I ask you what will happen to the pressure, pressure will always decrease in throttling. Throttling will always give rise to decrease in pressure of the gas. But whether there is a decrease in temperature or increase in temperature, then the Joule Thompson coefficient will decide. If it is negative, then there will be an increase in temperature. If it is 0, then the temperature will remain constant. And if it is greater than 0, then the temperature will decrease. You must remember this thing. It is very, very important concept in throttling. Joule Thompson coefficient, the slope of isenthalpic process on TP curve, on temperature pressure curve. So the temperature may increase or may decrease in case of real gas, depending on the sign of Joule Thompson coefficient. It can be negative, it can be positive, or it can even be 0. Is this clear to everyone? Is this all clear? When we will be having P1 upon P2 is equal to T1 is equal to T1 upon T2. When option B is correct? In which process option B will be correct? T is for constant volume, isochoric, constant volume, right? When we are having option C correct, when option C is correct, this is for isentropic. There is a difference between isentropic and isenthalpic, isn't it? And when do we have option D correct? Is it possible to have option D for an ideal gas? I don't think so. Okay, so let us move to question number 3. Let us quickly move to question number 3. Yes, reversible, adiabatic and isentropic. Shall we move to the next one? Beautiful question, simple yet beautiful. The next question, please let me know the answer to the next one. Question number 3. Quickly solve it. These are conceptual questions. In basic thermodynamics, you will get more. There is a high probability of having the conceptual question rather than numericals. But in applied thermodynamics, mostly question will be framed in the form of numericals. What is the correct answer to question number 3? An ideal gas undergoes expansion. It means volume will increase according to the process PV to the power 0.5 is equal to constant. The temperature of the gas during this expansion, it can be called as polytropic expansion. The process can be polytropic. What will happen to the temperature of the gas during the expansion? Can you just let me know before going forward? Can you just let me know? If there is an equation y is equal to x to the power a. My question to everyone is, as x increases, what will happen to y? If we increase x, what is going to happen to y? There is a relationship y is equal to x to the power a. This relationship I tell the students in fluid mechanics also. This is the mathematical expression, the relation between x and y. If we increase x, what is going to happen to y? Can you just let me know? And if anybody is having any doubt in understanding any of the concept, you are most welcome to ask through the comment section. I keep on having an eye to the comment section. Y, variation in Y, the change in Y will depend on the value of A. As X increases, and Y will increase if A is positive. Y will decrease if A is negative. Y is equal to 1 if A is equal to 0. Isn't it? If A is equal to 0, Y will be constant. So it will be decided by the sign of A. And if you see the relation between temperature and volume, we need to develop. So PV to the power 0.5 is equal to constant. Can we say PV is directly proportional to T? So we can say P is proportional to T by V from the ideal gas equation. From the ideal gas equation or ideal gas law, PV is directly proportional to temperature. So P is proportional to T by V. Put the value T by V into V to the power 0.5 is equal to constant, or we can say T into V to the power minus 0.5 is equal to constant, or we can say T is proportional to V to the power 0.5. By increasing volume, the question is by increasing volume, because A is positive. Because A is positive, by increasing the volume, temperature will increase, isn't it? You can relate with this. By increasing the volume, the temperature will increase because the power is positive. Yes, because the power is positive. Option B is the correct answer. Option B is the correct answer. What will happen to the pressure? What will happen to the pressure? So by increasing volume, if I ask you what will happen to the pressure, is this clear? This relationship. Now, if I would have asked you about the pressure, variation in pressure, we could have said pressure is inversely proportional to V to the power 0.5, or we could have said pressure is proportional to V to the power minus 0.5. If the volume is increasing, then pressure would have decreased. The pressure would have decreased. Is this clear to everyone? The expansion will give rise to decrease in pressure. I hope it is clear. That is how you can relate. The next one, question number 4. Let us move to the next one. Any doubt? If anybody is having anything to ask, you just let me know through the comment box. And share this session to your WhatsApp groups as well as to your Telegram groups, so that more and more people can join, and they can, if they are not able to join, they can watch the recording and they can check their understanding about the concept. The next question, question number 4 on the screen. The next one, question number 4. There are 16 questions in total. Yes, question number 4. Here, adiabatic index is 1.4 is compressed ideally. What is ideal compression? What is the meaning of ideal compression? What is ideal compression? Ideal compression is reversible adiabatic compression, which is happening in Carnot cycle. In Carnot cycle, compression and expansion are reversible adiabatic. That is ideal cycle. And heat addition and heat rejection are taking place isothermally. So ideal heat addition and heat rejection are isothermal, and ideal compression and expansion are reversible adiabatic, isn't it? What is the correct answer? From an initial state of 1 bar, P1 is equal to 1 bar, T1 is equal to 300 Kelvin to a final temperature of 600 Kelvin. The value of final pressure, very simple. What is the value of P2? You can say T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. That is for ideal gas undergoing reversible adiabatic compression. Or from here we can say P2 is equal to P1 into T2 by T1 to the power gamma upon gamma minus 1. Put the value, you will get the answer. P1 is equal to 1 bar, T2 is equal to 600 divided by 300 and gamma is equal to 1.4 divided by 0.4 will give you the answer in bar. What is the correct answer you are getting? Okay, good, Rohan, Ankit, Satya. Where are others? Where are others? Reversible adiabatic compression. For reversible adiabatic process undergone by ideal gas, you need to remember PV to the power gamma is constant, one relationship. The second one is T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma, or you should also remember V1 by V2 to the power gamma minus 1. So as the, what we can say, as the temperature increases, pressure will also increase and volume will decrease because gamma is greater than 1. Or we can say as the temperature decreases, pressure will also decrease and volume will increase. That is happening. Reversible adiabatic means Q is equal to 0. Reversible adiabatic, no heat transfer taking place. 11.3. Are you getting 11.3? Are you guys getting 11.3 or not? Why I am not getting response from every one of you? Why I am not getting the response from each one of you? The session is all for your practice. The more you practice, the more you solve without any help, the more confidence you build. And the examination is all about developing the confidence. Let us move to question number 5. Beautiful, marvelous question and very standard. Can you solve the question number 5th? Can you guys solve question number 5th? Question number 5. An ideal gas gamma is 1.39 flows in a pipeline at 450 degrees Celsius. There is a pipeline at 450 degrees Celsius. So Ti is equal to 450 degrees Celsius and 20 bar. Pi is equal to 20 bar. A rigid insulated and initially evacuated vessel. There is a vessel is connected like this. The question is from unsteady flow process. The question is from the unsteady flow process. How to apply first law of thermodynamics for how to analyze unsteady flow process. What is the correct answer? Yes, I have started getting the answers. The standard result you should always memorize, or you should always remember the standard result. How? If it is rigid, if it is insulated and initially evacuated. If these three things are given, in the question, then we can say the final temperature T2, the process is 1 to 2. The final temperature is gamma times of Ti. That is what we will be getting. So T2 is equal to 1.39 into Ti. And one more thing you must remember, that it must be in Kelvin. The temperature must be in Kelvin. So it is 450 plus 273. So T2 will come out to be, what is the value of T2? You will be getting 450 plus 273. 723 into 1.39. That is 1004.97 minus 273. That is Kelvin. And in degrees Celsius, T2 is equal to, subtract You have to convert. Kelvin is equal to degree Celsius plus 273. That is how the conversion is taking place. T2 is equal to 731.97 degrees Celsius. So you must remember the standard result here. Is this clear? And how we are getting this result? Option D is the correct answer. I have already solved the question by using the standard result, but how we are getting the standard result? Let me quickly discuss about the unsteady flow process. If we talk about the mass conservation, here 1 is state 1, initial state of the system. 1 represents the initial state, 2 represents the final state, and I for inlet. These are the notation, and E for exit, inlet or entry, and E for exit or outlet. These are the notations. If we apply the mass conservation, so we can say m dot I minus m dot E is equal to change in mass in the control volume. And because the system is initially, if you see, system is initially evacuated, it means m1 is equal to 0. This is m dot. Because the system is initially evacuated, that is m1 will be 0, and there is no outlet, so that is why m dot E is also equal to 0. So what we are getting, m dot I is equal to m dot 2. That is one relationship. Then if we write energy equation or steady flow energy equation, if we write the first law of thermodynamics, I am directly writing the expression. It is m dot I Hi plus q dot minus m dot E He minus w dot is equal to U2 minus U1, change in internal energy of the control volume. That is how we are getting the steady flow energy equation. And if we put the values, I hope you are comfortable with developing this energy equation or first law and mass conservation. Entry mass minus exit mass is equal to change in mass in control volume. That is what I have written. M dot in minus m dot out is equal to change in mass in control volume. Similarly, if we talk about the energy conservation, what is that? That is E in minus E out is equal to change in energy in control volume. That is what it is. So because there is no outlet, this term will become 0. There is no heat transfer because it is insulated. Because it is insulated, it is rigid, so there is no work transfer. There is no work transfer. What we are getting, and we can say that will give m dot Hi is equal to m2 U2 minus m1 U1. And because it was initially, this is m dot. It is initially empty. The vessel is initially empty. So m dot I into Hi is equal to m dot 2 into U2. That is our expression, and we have already got m dot I is equal to m dot 2. These two will get cancelled out. And what is Hi? Hi is Cp into Ti. What is U2? That is Cv into T2. And from here we will get T2 is equal to Cp by Cv into Ti. That is how this is gamma. That is how we are getting. I hope it is clear. So that is how we are getting this result. The question could have been twisted by giving some heat transfer also, or by giving some work transfer also. Then the relationship, this relationship will not be applicable. So you should understand how you are developing this relationship from the mass conservation and energy conservation for unsteady flow process. Is this clear to everyone? Is it all clear to everyone? Let us move to the next one then. Yes. The next question, question number 6. The next one, question number 6. Quickly solve it. We are increasing the difficulty level. It is very simple question. A certain quantity of gas undergoes the polytropic process PV to the power 1.3, that is the polytropic index, N is equal to 1.3, from an initial state of 1.5 megapascal and 0.09 meter cube to a final pressure 7.5 megapascal. The work done by the gas in kilojoule is. What is work done for a polytropic process 1 to 2? Do you remember the formula for a closed system undergoing a polytropic process from 1 to 2? Yes, Agnik, if you know, that is how the questions are framed. Yes, you are correct. This year heat loss was also given. So sometimes they give you the work transfer, sometimes they give you the heat transfer. They want to check whether you are comfortable in developing this expression or writing the mass conservation and energy conservation for unsteady flow process or not. Yes, what is the correct answer? First of all, you should know whether there will be work done by the gas or work done on the gas. Will it be positive or negative? If you can see, because N is greater than 1, because N is greater than 1. What we can say, because there is an increase in pressure, so there will be a decrease in volume. There will be a decrease in volume, so it is compression. We can call it as compression, and compression work is negative. So C and D cannot be true, cannot be correct. C and D cannot be correct. It is compression work, so it must be negative. If we write P1 V1 minus P2 V2 upon N minus 1, that is work transfer in a polytropic process 1 to 2 undergone by a closed system. And we can write it as M into R into T1 minus T2 upon N minus 1. Isn't it? Or no need to write. We need to find out the value of V2. Can you find out the value of V2? We know P1, we know V1, we know P2. The only problem is V2. So what we can say, P1 V1 to the power 1.3 is equal to P2 V2 to the power 1.3. From here we can find out the value of V2. What is the value of V2? From here we can find out the value of V2. The value of V2. What is the value of V2? 0.026. 0.026 meter cube. Put the value of V2 in the equation, you will get the answer. And your option answer should be in kilojoule. You should take care of the unit. Put the values, you will get the answer. Option B is the correct answer. Are you getting minus 200? Are you guys getting minus 200? B is the correct one. B is the right answer. Next question. Very, very important or very, very beautiful question. There is an insulated vertical cylinder. There is an insulated vertical cylinder. This is insulated cylinder. Encloses 0.1 kilogram of argon with the help of frictionless non-conducting piston. This is our control volume, or this is our system. This is the system containing argon. Piston is also insulated and the cylinder is also insulated. In the figure, the mass of the piston is 5 kg and it initially rests on the bottom of the cylinder. Here the piston is initially here, bottom of the cylinder. This is the cylinder. The cylinder is connected to a nitrogen tank at 100 bar. This is the nitrogen tank. To a pipeline fitted with a valve. The valve is open and the nitrogen is slowly admitted into the cylinder. During this operation, the piston is lifted through a height of 10 centimeters. This is the height by which the piston is lifted. Through a height of by the nitrogen gas. The initial pressure and temperature of argon gas, this is P1, this is T1, and the final temperature, this is T2, and Cp and Cv for argon are given. Then the question starts. The first part of the question is the work done by the argon gas in kilojoule during the process is, because it is insulated, the system is insulated, so it is having no heat transfer. Q is equal to 0. So it is insulated, so Q is equal to 0. So this is the reversible adiabatic process. Because it is a slow process, it is adiabatic process. The process is adiabatic. For an adiabatic process, how to calculate the work transfer? Work done by the argon, will it be positive or negative? Again, because it is the compression, argon is getting compressed and compression work is negative. Because it is compression work, then it will either be option C or D. So work done for a process 1 to 2 for an adiabatic is equal to P1 V1 minus P2 V2 upon gamma minus 1. Or we can write it as M into R into T1 minus T2 upon gamma minus 1. What is gamma? Gamma is equal to Cp by Cv. Cp and Cv are given. What is the answer to this question? Cp is 520, Cv is 312. What is R? R is equal to Cp minus Cv. That is 520 minus 312. So we know mass of argon. Can you solve it? Mass of argon is given as 0.1. R is Cp minus Cv. T1 and T2 we are already given with. Put the value, you will get the answer. What is the answer to this question? Solve the question and let me know the answer. (0.1) into R is 520 minus 312 into T1 minus T2. T1 is 300 minus 320 upon gamma minus 1. Gamma is Cp by Cv. It will be negative because this value is negative. What is the answer? Are you getting option C? It will be minus 0.624 kilojoule. Minus 0.624. Minus 0.624. I hope it is clear to everyone. And the next part of the question is, work done by the nitrogen during the process is. What is the work done by the nitrogen during the same process? What is the work done by the nitrogen? The work done is by the nitrogen is work done on argon. Work done on argon plus work done on piston. To move the piston, some work will be done by the nitrogen only, because the piston is moving by a height of 10 centimeter. So that will be the total work done by the nitrogen. So 1 is 0.624, that is kilojoule, plus the weight of the piston, that is M into G, and the height by which it is rising is H. So we can say M into G into H. This will be the work done by the nitrogen. 0.624 plus what is the mass? That is 5 kg. What is the mass of the piston? 5 kg into G, that is 9.81, into H, that is 0.1, divide by 1000 because we want in kilojoule. That will be the answer of work done by nitrogen. What is the answer to question number 8? Question number 8, quickly. This is the work done on piston. Work on piston. Weight of the piston into the distance. Force into distance. it will be 0.6289 kilojoule. That is the work done by the nitrogen. Option B is the right answer for question number 8 as well. For question number 8 also, option B is correct. Is this clear? Can we move further? Question number 9. Very simple question. I want everyone to give me the answer for question number 9. I am not giving you the hint for question number 9. Very, very simple. What is the answer to question number 9? Question number 9. Pressure. Is it a path dependent quantity or path independent quantity? Pressure. It depends on path or it is a property? Pressure is a property. So it is independent of path. It only depends on initial and final states. And is it intensive property or extensive property? It is independent of mass also. It is intensive property. And heat is the energy transfer by virtue of temperature difference. That is called as heat. So heat depends on path. It is path dependent quantity. It is not a property, neither intensive nor extensive. So we can say P2X and Q1. P2X and Q1. B is the correct answer. B is the correct answer for question number 9. Correct, Sagnik. Rohan. Well done. Where are others? Question number 10. All question number 10. What is the correct answer for question number 10? Please do solve the questions. These questions are for your practice, for your confidence, improving your confidence, and for your understanding of the concept. And if you have anything to ask, you can just let me know through the comment section. Right? What is the answer to question number 10? There is an object of mass small m in a wooden box having a mass capital M. The box is having a mass capital H. Falls through a height h. It is falling through a height capital H. Under the influence of gravity in vacuum. The work done by the object on the box is, because it is in vacuum and vacuum does not offer any resistance. The vacuum does not offer any resistance to motion. So the resistance force is equal to 0 and work is equal to force into perpendicular distance. So the work done will also be 0. Option A is the correct answer. Question number 10, option A. Question number 10, it is option A. Yes, Peru. Well done. Is this clear? Whenever you are having a vacuum, the vacuum does not offer any resistance. So resistance force is equal to 0 and work is force into perpendicular distance. Question number 11. The next one. The next question. An ideal gas is known to obey following relationship. The specific internal energy is given by this expression and the product of pressure into specific volume is given by this expression. They are a function of temperature, where U is the specific internal energy kilojoule per kg, T is the temperature in degrees Celsius, and P is the pressure in kilopascal, and V is the specific volume. Specific heat at constant pressure, what is Cp? Because it is an ideal gas, do you remember the formula for Cp? Del H by del T at constant pressure. That is Cp, and for an ideal gas, Cp can be written as total derivative of H. That we can write because H is a function of temperature only. Because H is a function of temperature only, for an ideal gas. So the partial derivative can be replaced by the total derivative. And what is H here? And H is equal to U plus PV. So Cp will be equal to, then Cp will be equal to d by dt and then U plus PV. Put the values, you will get the answer. So d by dt and then U is 200 plus 0.718T plus 0.287T plus 0.287 into 273. Do the differentiation with respect to temperature. So the value will be 0.718 plus 0.287. That's it. That will give you kilojoule per kg Kelvin. Without solving also you could have got the right answer, isn't it? The correct answer for question number 11 is D. Yes. But you should know how to solve it. You should know how to solve it. Ready for the next challenging question? Are you guys enjoying? No doubt at all? Anybody is having any doubt? How is your preparation? Question number 12. Do you have any idea about the compressibility factor? What is compressibility factor? It is the measure of deviation from an ideal gas behavior. The compressibility factor Z is the measure of deviation from an ideal gas behavior. If Z is equal to 1, then the gas is treated as ideal gas, and if Z is not equal to 1, then it is non-ideal. The compressibility factor decides whether the gas can be treated as an ideal gas or not. That is called as compressibility factor. The question is to find out the compressibility factor for this methane gas. Compressibility factor. Can you solve it? Question number 12. What is Z? Z is given by pressure of the gas into specific volume upon specific gas constant into T. PV by RT, where R is specific gas constant, specific or characteristic gas constant. What is the unit of characteristic gas constant? What is the unit of specific gas constant or characteristic gas constant? That is, the SI unit is Joule per kg Kelvin. So R is equal to R bar by molecular weight, where R bar is universal gas constant. I hope you know that, universal gas constant. And tomorrow we will be starting another series, if you guys are aware, for 2023 aspirants, GATE 2023 aspirants. We have started another free series on your YouTube platform, BYJU'S YouTube platform. And tomorrow we will be starting the theory as well as numerical for the thermodynamics. Tomorrow at 8 p.m. I will be coming live again, and we will be having another free series on BYJU'S English YouTube channel. The series is Mastering Gate Concepts for 2023 aspirants. So do join me tomorrow at 8 p.m. We will have the basic understanding about the thermodynamics in tomorrow's session, and then we will start the series, and there will be numerical sessions, practice sessions, as well as the theoretical or conceptual session. So it is the combination of concept as well as numerical practice, right? So tomorrow I will be having 2 classes. This is the schedule for tomorrow on BYJU'S YouTube channel. At 4 p.m. we will be having practice session, practice for second law plus entropy. That is the atomic series. At 4 p.m. we will be having the atomic series, and at 8 p.m. tomorrow we will be having the series for GATE 2023 aspirants. And I am going to start the thermodynamics. Tomorrow's session is all about the weightage analysis and the preparation strategies and the books you should refer and how to prepare the thermodynamics in the best possible way. So tomorrow's session is very, very important to understand how to prepare the thermodynamic subject for your GATE 2023 examination. So do join me tomorrow at 4 as well as tomorrow at 8 p.m. on your favorite BYJU'S platform. All right. And do share the information with your friends also, those who are appearing for 23 as well as 24 examination, those who are preparing for GATE examination. These series are going to be very, very useful and they are completely free. So what is the answer to the compressibility factor? Compressibility factor, you should take care of the unit. Put all the parameters in their SI unit. The pressure is 18.56 megapascal, 18.56 into 10 to the power 6 pascal. Then specific volume. What is the specific volume? Volume per unit mass. And what is the volume? Volume is 6.4 liter. So in terms of meter cube, 6.4 into 10 to the power minus 3. And per unit mass, it is 1 kg. That is the numerator. Divide by what is the denominator? R. What is R? Is it given? It is not given. So we can say it will be molecular weight is given 16 kg per kilomole. So it is 8.314 joule per mole Kelvin. And if we divide by molecular weight, that is 16, that is kg per kilomole. So convert kilomole into mole, then 16 by 1000, then kg per mole into the temperature. What is the temperature? Temperature is given in degrees Celsius. So it will be 273.13. What will be the answer to this? If you put the values like this and solve it, then you will get the compressibility factor. Do let me know the value of compressibility factor. What is the value of compressibility factor? Are you getting 0.799 something? Are you getting 0.799 something? B is the correct answer, 0.8. Are you guys getting 0.8 or not? I have not received the answer from any one of you. Sagnik had given the correct answer, option B. Well done, well done. Shall we move to question number 13, the next one. Question number 13, very, very beautiful question. Let me see whether you will be able to get me the correct answer or not. Question number 13. All the question, there is a slab of mass 200 kg and volume. There is a slab of mass 200 kg and volume 0.2 meter cube is raised slowly in a vertical direction by a massless row like this through a height of 2 meter. 2 meter from the bottom of a fresh water lake. There is a fresh water lake. This is water. And it is rising by 2 meter. Depth of the water in the lake is 10 meter. This is 10 meter. If the density of fresh water is 1000 kg per meter cube and acceleration due to gravity is 10, work done by water on the block is this the question from thermodynamics or fluid mechanics? If the question is from thermodynamics or fluid mechanics? What is the answer to this question? This is the slab. Work done by water on the block is. What force water will exert on the block? Force by water on the block. That is force by water into the distance 2 meter. And what is the force by water? That is the buoyant force into 2 meter. The buoyant force into 2 meter. And what is the buoyant force? That is density of water into G into volume of the slab, because it is completely submerged, into 2 meter. That will give you the answer. Density of water is 1000, that is 10, and volume is 0.2 into 2, that is joule. In kilojoule, how much is that? The work done by water is 4 kilojoule, isn't it? Work done by water is 4 kilojoule. And what is the total work done? The total work done is equal to the external force, or the total work done is equal to force into 2, and the force is equal to weight of the block. So the total work done is equal to mass of the slab into G into 2, and mass of the slab is 2000 into 10 into 2. So it will be 40 kilojoule. That is the total work required for moving the block, and 4 kilojoule is done by water. The remaining will be external work done. The remaining will be external work done. So the external work done will be equal to, from this we can say, external work done is equal to total minus work done by water. That is 36 kilojoule will be the work done by the external force. This is external force. The work done by the external force is 36 kilojoule. Or the external force exerted, we can easily find out. We can easily find out the external force required to move the slab by a height of 2 meter, isn't it? We can find out the external force. That is F external into 2. So the external force will be equal to 18 Newton. 18 kilonewton, sorry. The external force required will be 18 kilonewton. Is it clear? One more question we will discuss, and then I will give you couple of questions for assignment. This is very, very beautiful question. The diagram is not correct though. The next question, last question for the day. Can you guys solve it? A bulb is connected to a U-tube with long vertical column as shown in the figure. This is the bulb. Cross-sectional area of both sides of the U-tube is 3 centimeter square. That is A. 3 centimeter square. That is the cross-sectional area, which is constant. Water is poured in the right side open column of the U-tube. Here the water is poured. This is water. In the right side open column of the U-tube, such that the trapped air in the left column, there is an air in the bulb. The left column, and the bulb above water has a volume of 1000 cc. This is the volume which is 1000 cc. And a pressure of 105 kilopascal. So PA is equal to 105 kilopascal. Ambient pressure is 100 kilopascal. Outside pressure, here the pressure is PATM. Atmospheric pressure is 100 kilopascal. Density of water is given 1000. Acceleration due to gravity may be taken as 10. When 90 cc of kerosene oil, this is the situation 1. This is the first situation. And in the second situation, when 90 cc of kerosene, so here it is not kerosene. Here and here it is water only, but there is a kerosene poured. When 90 cc kerosene is poured, On the right side of the U2, water level in the left column rises by 10 centimeter. Earlier, the water level was here. This was the initial level. The diagram is not perfect actually. So the water level will rise by 10 centimeter. This is 10 centimeter. So what is the pressure in the bulb? PA dash will be how much? That is the question. Can you solve it? Have you understood the question? Let me make the question clear first. First step is to get the clarity in the question and then you need to solve it. Let me make the question clear to you. Look, initially there is a bulb which is connected with a U2 manometer, and when water is poured, this is water. This is water. So this is the situation of water in the, this is the situation, or let me, this is water. And then what? So the pressure in the bulb is given as 105 kilopascal. Now what is happening when kerosene is poured in the right limb? So this is the kerosene. Then because of kerosene weight, the level of water in the right limb will fall down a little bit. This is where the level of water will go. Earlier it was here. Now, and there is a rising of water level in the left limb. And the rise of water level in the left limb is given as 10 centimeter. What is the new pressure? What is the new pressure in the, they are not same actually. This level will not be same. Then what will be the value of PA dash? Can you guys solve it? What is the answer? So we need two equations. Look how to solve it. That is, let us say, initial situation. That is, let us say, initial level. This is initial. And here it is PA, here it is PA dash. And this is, let us say, let me call this to be H. This is completely water. And then the water will be something like this. The rise of water from the initial level in the left limb is 10 centimeter. Then it will become PA dash. This is water. And then there is a kerosene. Can you just let me know how much height kerosene will occupy? Can you just let me know how much height kerosene will occupy? Because the area is given as 0. What is the area? What is the area? 3 centimeter square. Area is 3 centimeter square. Area is 3 centimeter square. Can you just let me know how much height the kerosene will occupy? So we can say area into H of kerosene is equal to 90 cc. So we can find out H of kerosene as 90 by 3. 30 centimeter, isn't it? So this is 30 centimeter. Now if you write the pressure equation, the question is not from, this is very beautiful question. You write the pressure equation for the first case. So we can say PA, the pressure here will also be PA because it is a gas. It is air. And air is not having any variation in pressure. So here it is PA, then this will be PATM. So PA is equal to PATM. Here it will be PATM plus rho of water into G into H. That is our first equation. The second equation we can say PA dash. If we take this, the same initial level as the datum line. So here it is PA dash now. So PA dash plus rho of water into G into 0.1 is equal to, we can say pressure at the top is again PATM plus we are traveling in kerosene rho K into G into 0.3 plus how much this is. Earlier it was H, now it isn't it H minus 10 centimeter? Isn't it H minus 10 centimeter? Because the volume of water will remain constant. If there is a rise of 10 centimeter, if there is a rise of 10 centimeter of water level in the left limb, there is a fall of 10 centimeter in the right limb. So it is rho of water into G into H minus 0.1. These are the two equations. If you are comfortable, if it is about the pressure equation for first case and the pressure equation. Subtract 1 and 2, then we can say PA dash plus rho of water into G into 0.1 minus PA is equal to PATM getting cancelled out, then rho K into G into 0.3 plus rho of water into G into H minus 0.1, then it will be minus rho of water into G into H. Isn't it? This minus rho GH will get cancelled out with this, and we can say PA dash is equal to PA plus rho of kerosene into G into 0.3 plus or minus rho of water into G into 0.2. This will give you the answer. This will give you the answer. PA dash will be equal to PA is 105 plus what is density of kerosene? 700. It is given as 700. Passive gravity is 0.7 because it is in kilopascal. So we can write 0.7 into 10 into 0.3 minus rho of water 1 into 10 into 0.2. That is kilopascal. So it is 105 plus how much is that? 2.1 minus how much is that? 2. So 105 plus 0.1, that is 105.1 kilopascal. That is the new value of pressure, isn't it? The question is not from the thermodynamics as such, the question is from the fluid mechanics, isn't it? There is a close connection between FM, HT and thermodynamics. There is a close connection between fluid mechanics, heat transfer and thermodynamics. So you should be able to relate the concept of these three subjects, and when the question coming from these three subjects taken together, then the question becomes very, very beautiful. The next question is your assignment question, and I will again come back tomorrow at 4 p.m. as well as 8 p.m. to discuss the thermodynamics. At 4 p.m. I will be coming for discussing the second law, question practice for the second law and entropy, and in the evening we will have the basic discussion about how to prepare the preparation strategy for thermodynamics and applications. What is the weightage, what are the various books, that will be the session, and then we will start full-fledged discussion for the concept and practice. This is the first part, question number 15, and there is one more part, question number 16. That is all from my side. I hope you have enjoyed the session, you have liked the session. Please do share the link of this class to everybody else in your friend circle so that they can also try these questions, practice these questions, so they become confident and they improve their rank in their upcoming examination. That is all from my side for this session. Stay safe, stay motivated, and see you all tomorrow at the same time at the same place. Thank you guys. Thank you very much. Take care. Jai Hind.